Hello, and welcome to this online training on Intel Nios V processors software development flow. Feel free to pause, move forward, or go back as you need during this presentation. At the top right of the presentation, you will find a list of helpful links and resources on the subject. Let's get started. The Intel FPGA portfolio supports this transformation, including discrete and integrated FPGAs that are expected to improve processing efficiency, task specificity, and connectivity. Intel FPGAs can provide a variety of workloads in network processing as well as compute and storage acceleration. FPGAs are mass-produced, standard product ICs that can be reconfigured in the field to accelerate virtually any digital algorithm. They offer greater throughput, execution speed, and energy efficiency than CPUs on computationally intensive parts of algorithms, but with the ability to adapt quickly to changes in algorithms, data patterns, or performance needs. They can be reconfigured in the field to accelerate virtually any digital algorithm. They are available in 5 current families: Max, Cyclone, Aria, Stratix, and the newest family Agilex, all with increasing capacity, performance, and feature sets. The objectives for today's e-learning are to describe the software development flow with Nios V processors, the necessary tools and steps to implement it, and to integrate the software development flow after hardware design for a Nios V processor application project, using Ashling RiscFree IDE for Intel FPGAs. Nios V processors are the next-generation soft-core processors based on the open-source RISC-V instruction set, designed for Intel FPGA devices. The Nios V processor system design flow integrates hardware and software development. After analyzing the system requirements, the Nios V system is divided into a hardware flow and software flow to achieve the whole design. The hardware integration flow of a system design for Nios V processors starts from defining and generating a system in Platform Designer. For this, Nios V cores and standard components need to be added to this design. The design needs to be generated and integrated into an Intel Quartus Prime project, then assign pin locations, timing requirements, and other design constraints. The project can now be compiled for the device and is ready to download the FPGA design to the device. For this purpose, you can use the Intel Quartus programmer. After this process is completed, the steps for the software flow need to be followed to complete the system design. To take a look in detail at the steps for hardware integration and flow, you can go to the link provided in the resources section at the top of this presentation. Here is a summary of each step for software development and the tool used for each step. As part of this flow for software development for the Nios V processor application, inside Platform Designer, you now have available the BSP editor for the generation of the BSP files needed for software development. Then, through the Nios V command shell provided with Intel Quartus Prime software install, you can generate the application CMake build file. With Ashling RiscFree IDE for Intel FPGAs, you can import the BSP and application CMake build files to continue to debug and build the Nios V processor application. You can program your FPGA with the SOF file produced from the hardware flow in order to use the Nios V application and debug in Ashling RiscFree IDE for Intel FPGAs. We will go through the tools described on each step in the upcoming parts of the training. To use the Nios V processor tools, you need a QSYS file for your system. The development flow includes the following steps to create a Nios V processor software. Generate a board support package, BSP, for your system. Generate and build your application software. Iterate through one or both steps until your design is complete. To use Nios V processors, you can install the Intel Quartus Prime Software Pro or Standard version. As part of the installation package, you will also find Ashling RiscFree IDE for Intel FPGAs embedded, or you can also install the version as an individual file. Please go to the links provided in the resources to learn more about the versions supporting each Nios V processor IP and find the options for specific devices and compatibility. Nios V processors also require a license for use in the Intel Quartus Prime software. The link to the Self-Service Licensing Center resources is also provided in the same mentioned section for this course. A Nios V C++ application project has the following features. Consists of a collection of source code and a cmakelists.txt. The cmakelists.txt compiles the source code and links it with a BSP and one or more optional libraries, to create one .elf file. One of the source files contains function main. Includes code that calls functions in libraries and BSPs that will be generated with Intel Quartus Prime software and BSP editor in Platform Designer. The command shell for Nios V is a utility tool in the Intel Quartus Prime software. With the command Nios V app, the utility tools create the application cmakelists.txt. You can use Ashling RiscFree IDE for Intel FPGAs to modify the source code in an Eclipse-based environment. There are two parts that are necessary to work with the software development, which are the board support package and the application project, which is a Nios V C++ project. Inside Intel Quartus Prime software in the Pro version, you can go to the Tools menu and open Platform Designer. To use BSP Editor and Generator inside Platform Designer, you can go to the File menu and choose New BSP option. The BSP Editor is used for create or modify a Nios V processor BSP project that has been integrated into Platform Designer. Edit settings, linker regions, and section mappings, and to select software packages and device drivers. You can open a QSys file to begin working with the BSP editor or create a new file. In the case of the Standard Edition, you can invoke the BSP editor GUI using Nios BSP editor in the command shell. A basic software system comprises of a board support package, BSP, and application project file, app. Inside Platform Designer, when you go to the File menu and New BSP option, the window shown here will appear. You can create a BSP settings file and adjust the system file and Quartus project settings on the right buttons with 3 dots. Then you can create your file. Here you can choose the operating system for your design. You can have 3 options for operating systems for the different variants of Nios V processors. These are Intel HAL, Micrium Micro C, OS2, FreeRTOS. You can find more information on configuration and tabs for settings for each option in the link for the Nios V Software Developer Handbook provided in the Resources section of this course. BSP stands for Board Support Package and provides a software runtime environment customized for a Nios V processor hardware system. After creating the BSP file, you will see the following window. The BSP project allows Nios V processor customization for your purpose, be it size, speed or other features. A Nios V board support package project is a specialized library containing system-specific support code. A BSP contains the following elements: hardware abstraction layer, device drivers, optional software packages, optional real-time operating system. All the settings and customization are compiled into a BSP library file that you can then use with your application projects. For specific configurations on booting and advanced settings, you can refer to the Nios V Processor Software Developer Handbook link provided in the resources. Inside the Main tab for the BSP editor configuration, you can find features like the System Clock Timer resource, which is used to trigger periodic events, alarms, and as a timekeeping device that counts system clock ticks. Other configurations can be made in this section like The default timestamp timer in a Nios V processor subsystem is the Nios V processor built-in internal counter. The stdio library allows you to communicate with your application using functions such as printf and scanf. The HAL can support the stdio functions provided in the GNU new lib library, among others. The advanced settings in the main tab of the BSP editor allow enabling functionalities to configure the HAL linker section under the HAL settings. For example, the alt_load function is a configuration done for the on-chip memory booting method where this function must be enabled to indicate the boot copier. Please refer to the Nios V Processor Embedded Processor Design Handbook provided in the Resources section to know more about configuration and booting methods. Typically, the linker section allocation scheme works during the software development process because the application is guaranteed to function if the memory is large enough. Inside the BSP Linker Script section tab, you can manipulate the linker script using the following methods: add a memory region, maps a memory region name to a physical memory device; add a section mapping, maps a section name to a memory region. In the BSP Enable File Generation tab, you can find the generated files to continue working with the rest of the system design flow. The drivers and SRC contain the source and header files. The operating system source code has a separate directory where the CRT0's source file containing the HAL-C runtime startup code is. The Nios V Processor Tools allows you to construct a wide variety of complex embedded software systems using a command line interface. From this interface, you can execute the command utilities, and use scripts, or other tools, to combine the command utilities in many useful ways. The Nios V Processor Tools command line utilities enable you to create software projects. In the example shown for the slide, you can see how the cmakelists.txt file is created through the command shell. The .elf file is also generated for the application project. There are examples described in the small table for some of the functions you can perform in the command line. To learn more of the command line examples and uses, you can go to the appendix of this training or visit the resources provided. The system H file is automatically generated by BSP editor settings and provides a view of the hardware present in the Platform Designer system and the settings for BSP. It also contains the hardware abstraction layer configuration and settings needed to develop software using HAL. The hardware abstraction layer is a lightweight embedded runtime environment that provides a simple device driver interface. It is used for connecting programs to the underlying hardware. HAL API allows access to devices and files using familiar C library functions like printf or fwrite. The HAL Peripheral Services provides your application with a set of services, typically relying on the presence of a hardware peripheral to support the services. By design, the HAL attempts to enable as many services as possible based on the peripherals present in the system hardware, and provides control over the initialization process, system optimization, and configuration. The changes made to the hardware configuration propagate to the HAL device configuration to avoid any inconsistencies in the IP. The HAL provides the following services: 1. Access to the device drivers to each device in the system. 2. The HAL API provide a consistent, standard interface to HAL services, such as device access, interrupt handling, and alarm facilities. 3. The system initialization performs initialization tasks for the processor and the runtime environment before main. 4. The device initialization service instantiates and initializes each device in the system before main runs. This is the integration of the different pieces for all the development of a Nios V processor system design. The three parts are necessary to complete the Nios V HAL project structure, emphasizing how the HAL BSP fits in it. The application project known as your program, or user project, created by the user. Then the HAL BSP project defined by the Nios V processor BSP settings and generated by the BSP editor in Platform Designer. The hardware system known as the Nios V processor system, is defined by the Quartus file. This is created in the Platform Designer system integration tool. The cmakelists.txt compiles the source code and links it with a BSP and one or more optional libraries, to create one .elf file. The cmakelists.txt file is the central component of the software project. It describes all the components of a software project and how they are compiled and linked. Those files are generated after BSP generation in Platform Designer is done. You will use the Nios V app with the command shell. To work with the files and Ashling RiscFree IDE for Intel FPGAs project, you will need the generated files and one of the source file that contains function main. This includes code that calls functions in libraries and BSPs generated in Intel Quartus BSP editor. Ashling RiscFree IDE for Intel FPGAs can run from Nios V processor command line or from the Start menu. Then the launcher will prompt for a workspace directory or create a new one. You will now create an application project. After workspace launch, click on Create Project on the left options. You can choose from the list the type of project and then click on Next. After assigning a name to the project, select CMake Driven, Empty Project Options and then CMake Driven on the right. The location for the project must point to where the cmakelists.txt file was created. You can now work with the application project inside Ashling RiscFree IDE for Intel FPGAs. This is a view of the main project window. These are some of the project navigation tools you can find inside Ashling RiscFree IDE for Intel FPGAs. You can look for the link on the Ashling RiscFree IDE for Intel FPGAs user guide and learn more about the project navigation tools and resources. You can create a hardware debugging session configuring the settings for the project. If you right-click on the options for the project created, you will find the option to debug as. Then go to Debug Configurations. On the left menu, choose Auto Detect Hardware Debugging. On the right, choose the project created before and the file with .elf extension. On the Debugger tab, choose the debug probe and JTAG frequency. 16 or lower is recommended. Click on Auto Detect Scan Chain for the device, tap selection of your device and core selection with Nios V processor. The Nios V processor tools provide many services and functions for your use. Intel recommends that you follow the following guidelines to simplify your development effort. Begin with a known hardware design. Refer to Nios V design example scripts that includes a set of known working designs. Begin with a known software example design. The Nios V design example scripts includes a set of pre-configured application projects for you to use as the starting point of your own application. Follow pointers to documentation. Many of the application and BSP project source files include inline comments that provide additional information. Make incremental changes. Regardless of your end application goals, develop your software application by making incremental, testable changes, to compartmentalize your software development process. In this summary table you will find GUI tools and command line tools for each task in the flow. This is a summary of steps for the software flow and tools to execute each step. The hardware project in Platform Designer is part of the hardware development flow. Then the BSP editor configuration and generation is necessary. You can program the FPGA with the Intel Quartus programmer. The command shell is used to generate with the Nios V app the files for the application project. Then you can use Ashling RiscFree IDE for Intel FPGAs for project build and debugging of your main application developed according to your system requirements. You can find examples to get started with Nios V processors design through the Design Store link provided in the resource section, or in our rocketboards.org website for examples with Nios V processors for Intel FPGAs. In the Design Store, you can find examples and different resources, or you can go to the Intel FPGA Support Resources website and target your development kit. You can also open examples from inside Intel Quartus Prime software to get started with tested designs. You can find them in the main window. You can find more information on the resources available in the section for this presentation at the top right, or you can go to intel.com and search for Nios V processor landing page, and take a look at the resources, quick videos and tutorials to get started. You can learn of more commands commonly used for building scripts, generating and restoring scripts, create a linker section, as well as other functions in the guide provided from the resources. Intel provides multiple avenues in which to learn about Intel FPGA products. There is the Intel FPGA YouTube channel, which contains 5 minutes quick videos along with longer, more in-depth training videos. There is the Intel FPGA training website, where you can access e-learning courses made up of narrated slides presented in an interactive player, some courses with labs and demos. Lastly, you can also enroll in a live, instructor-led course presented either in person at an office local to you or virtually over the web. All instructor-led courses have hands-on labs exercises to practice the concepts you learn. If you need more assistance, Intel FPGA provides many self-help resources for you to access. For example, there are web pages, called landing pages, dedicated to specific FPGA technology like in high-speed interfaces. You can also view and post questions to the community forum, which is monitored by skilled Intel FPGA applications engineers. The Intel FPGA training team is always looking to improve our material and welcome any feedback you may have. Please email fpgatraining@intel.com with any of your thoughts or comments. This concludes the training. Thank you and have a good day.